I'm Nitin Dahad with EE Times, and I'm here at Intel IFS Direct Connect 2024 in San Jose with Aart de Geus.
Hi Nitin, thanks for having me.
Today it's all about Intel, and tell us a little bit about the essence of some of the announcements you made with Intel.
Well, as you know, this is a big announcement for Intel because they're essentially introducing the Intel Foundry. And these are easy words to say, but it takes a lot of work to have a Foundry be functional. And of course, Intel comes in with the technology, but they need a lot of enablement around that. And that is where Synopsys has worked with Intel very closely for the last 3 years. And to me, one of the highlights of what they're introducing is, of course, 18A for many reasons. A, because it's the most advanced node, and I love the fact that it's now measured in Angstrom, which is a whole new milestone. I started in the double-digit micron age, and then of course to the nanometers, and now the Angstrom. But what is particularly intriguing to me is that this introduction of the new Foundry is at the same time that we see a whole new age in semiconductors coming about. And that age, of course, is driven on one hand by all the AI demands, but it is enabled by the chip technology. So we're in the midst of that.
Indeed, and I think in terms of the specifics in working with Intel, it's basically being qualified on the 18A and then providing the PDKs and all that.
Yeah, people always think, oh, you introduce the technology and then you'll see how well it works. No, it's not like that at all. There's an enormous enablement that has to happen around that. For starters, you mentioned the word PDK, which is the process design kit or description kit. And that needs to be mapped into all of the tools so that they know how to take advantage of the new features. And the many new features, such as not only smaller transistors, but they call them ribbon FET, which is really a gate-all-around type structure, and also the power from the back of the chip, which is, in my opinion, something fabulous because it simplifies a lot of the internal routing on the chip and therefore gives, again, new opportunities for change. And so when we talk about enablement, we have to not only look at the technology as it connects to all of the tools, we have to then redo all of the design flows of how do you, as efficiently as possible, design large portions of a chip, and that includes not only the digital part, but also the analog part. And then on top of that, just as for bonus points, so to speak, this has opened up the age of multi-die, meaning that instead of being chips on a board, they're coming closer and closer together on a chip substrate, which is the chip itself. Exactly. And in addition, some will stack vertically. And in my opinion, that opens up a whole new age of possibilities for the next 20 years of more complexity. And then lastly, you have to have the IP blocks ready to go because otherwise nothing will happen. And here we have an agreement with Intel that is far and away the largest in the world of IP availability. All of our interfaces are being mapped to 18A, so that by the time people design in that technology, we have the goods to go.
Yeah, and I think you quite emphasized in your talk the need for that comprehensive IP library, especially for example, if you've got the 3D or the multi-die or the heterogeneous architectures, you need the connectivity, you need the IP and all that, but a lot more than that as well.
Oh, absolutely. You need literally everything because design today is really redesign or reuse of a large portion and then modifications for the next application. And so one of the things that characterizes this new age that is really a new continuation of Moore's Law, but in a very different fashion, is two things. A, that the architectures are being redesigned for the specific application. So you will do less, but you'll do it much faster. And AI is just a perfect example of wanting more and more and more of that. Yeah. And so that's sort of the functional architecture, but the form architecture is really multi-die. Yes. And you bring those two things together, you have what I like to call the SysMore age, or systemic complexity, but still with a Moore's Law ambition. And ambition is everything in our field because tomorrow's got to be better than today, and today is already a lot better than yesterday.
Exactly. One of the things also you got animated about was you talked about getting to the single-digit Angstrom technology by the end of this decade. What gets you excited about that, and what are the things that need to happen before that happens?
Well, for starters, angstroms are pretty small, right?
Yeah.
And I love the fact that in the word angstrom is the word angst, because that's precisely how everybody felt when the notion was, hey, we're going to get now close to be measured in angstroms. Yeah. And so 18A, of course, is a prime example of now measuring in angstrom. And it was interesting because Pat also communicated that the next is 14, and it's interesting because Ann Kelleher, who is really the technical driver inside of the company, then said, "Oh, by the way, we're working towards 10 for the end of the decade," and that fit exactly my predictions that we will continue on that pathway, which is sort of the classic, more the angstrom race, yes. But that is now being complemented by the multi-die, which is really a race for way more transistors availability and connectivity between chips. And connectivity between chips is just as difficult as the angstrom race. So we have now two parallel races going on, all with one objective, which is, hey, give AI a set of opportunities to do still dramatically more than what it can do today. And what is different than in the past technology has always been the driver for software. But now software is the puller. It wants more. And so all the AI people say, so what takes you so long? How come you cannot do more chips? And I think that's exciting because that will drive a couple of decades of unbelievable advances.
And I'm going to throw something in here. We've got Synopsys user group snug coming up. And what can we expect, or what can you say to give us a sneak peek?
Well, I want to, for starters, say, I don't know if you know, but there's a new CEO in town, right? Sachin Ghazi, and so this is now his job to do this. But, and I don't want to foreshadow what he will be talking about, but for sure, what you will see is that Synopsys is absolutely in the middle of this enablement in every aspect of high technology. And a term that I think I coined in the 1990s, I think still applies. We are the heart of high tech, right? We are the people that are sitting around and under an Intel. We are the people that are sitting around the customers that design these advanced chips. And by the way, we ourselves are a fundamental innovator in using AI to make this happen. And so I always like to use the visualization of the Escher hands, the hand that draws the hand that draws the hand, because we are part of that loop. We are part we use computers to run AI, to help people design faster chips, to go into faster computers, to run EDA, I guess. And so it's a loop that has turned out to be the essence of why exponential change is actually possible.
That's kind of that... Which came first, the chicken or the egg?
Yeah. Well, we're neither the chicken nor the egg. We are the ones that make this picture actually turn around and around, and but there's another implication in that, and the number of parties that have to be part of this circle is actually larger, and therefore SysMore, systemic complexity, but with an exponential Moore's law expectation. And in systemic complexity, what changes is that one moves from additive behavior to multiplicative behavior. And that's another way of saying, we so often say success. It's the sum of our efforts. No, it's not. It's the product, a single zero, and everybody gets zero. We are so interdependent. And therefore, teamwork is absolutely the core skill to make these very advanced technologies come about. And there too, massive progress.
And I think, I don't want to labor the point, but that really plays into that global ecosystem and that teamwork.
Well, and of course, the global ecosystem simultaneously has its own challenge because it's deglobalizing. And we've seen the dramatic impact this has had on productivity, on accessibility for certain technologies, and at the same time, it's being rebuilt to be more resilient to that. Now, personally, I still think that the world needs to find more of a common denominator because there are other issues around, and we are global. Everything is global. Yeah. But if in practical terms, the most advanced companies in the world have to work together, and we certainly are very close to all of them.
Well, Aart, pleasure talking to you again. Thank you.
Thanks for having me, Nitin. Thank you.